Hello students, welcome to Vipin Sharma Physics channel. Dear students, today I am going to discuss with you the concept of the internal energy of a gas. Well students, to explain the internal energy of a gas, let's go with an analogous example. Like in gas, there are molecules, correct? And if you go with the postulates of kinetic theory of gas, you all know that gas molecules are spherically hard to compress. They move in a random direction. Their collision with each other is perfectly instantaneous. The distance between the two molecules of a gas is called free path, and their collision is perfectly elastic. The volume V of a gas molecule is negligible as compared to the total volume of the gas, and the impact of the gas molecules on the walls of the container causes pressure. So dear students, these are the postulates of the kinetic theory of gases. S4, the molecules are spherical. H4, the molecules are hard to compress. R4, the molecules move in the random directions. I4, the molecules have instantaneous collision. D4, the distance between the two molecules is called free path. A4, their collision is perfectly elastic. V4, the volume of the gas molecule is negligible as compared to the total volume of the gas. I4, the impact on the walls of the container causes pressure. Just if you remember these, SHRI, the four letters, DEVI, another four letters, these are basically the postulates of kinetic theory of gases. So, I know you are smiling after reading this name. Well, it helps us to understand the postulates of kinetic theory of gases. So, let us take the help of this name. Thank you. Now, when you talk about the internal energy of the gas molecules, you all know if you follow these postulates, it's an ideal condition. Suppose you people make a timetable that you study from this hours to that hours physics, and that hours to that hours chemistry, and that hours to that hours maths, biology, and then you at this hour sleep, and then you get up in this morning at this hour. It is next to impossible, because it's right now you will not say, okay, I'm going to sleep, and it's say 4 o'clock, say I'm going to sleep. You cannot have the nap. It's habit. When you have to sleep, then you have to sleep. Similarly, if you follow these kind of things, then you are an ideal student. I should say these are the postulates. If you follow, then you are an ideal student. If all the molecules of the gas follow these postulates of kinetic theory of gas, I should say kinetic theory of gas, then students, we call it's an ideal gas. But practically nobody is ideal, so gas is also not ideal. when the behavior of the gas molecule deviates from the ideal, then it's called a real gas. Now, see, it's all theoretical explanation I am giving you. I am not using much chalk here. Dear students, in kinetic theory of gas molecules, we say that there is no molecular attraction. Like this molecule and this molecule, it's not going to have an attraction. You will put a question. Is it true? I said no. Molecule has attraction. When they are very close to each other, the molecular attraction comes into play. When they are far away, the molecules of the gas have no attraction. It means that when the molecules are far away, they don't have an attraction, it's going to be an ideal gas. And when molecules will be far away, when the volume is large and pressure is less. If you take a gas in a cylinder and the piston is here, the molecules have less attractions. If you move the piston more downwards here, the molecules will be closer, so there will be attraction. The behavior will be real now. If the molecules are far away, then pressure is less, volume is more. Then students, there is what? There is going to be an ideal behavior. The gas molecules will be behaving like an kinetic theory of gases postulates accordingly. Then the gas will be called a ideal gas. When the pressure is more, molecules are closer to each other, then we say molecules are very close, then there is a real gas. So attraction is there. Then students, the postulates of kinetic theory of gas is meant for an ideal behavior when the pressure is less, volume is more. Now, all the gas molecules have got kinetic energy linear plus kinetic energy vibratory plus kinetic energy rotational. The sum of the all possible energies of the gas molecule is called total internal energy of the gas. Gas molecule can have a linear motion, vibratory motion, linear motion, as well as circular motion, rotational motion. Then it has got different types of kinetic energy. Well, it's not controversial, but it's true that we can take vibrational motions, the to and fro motions can be linear like simple harmonic motion. So in general, it has got a kinetic energy due to rotational motion plus kinetic energy due to linear motion. Right? There is no molecular attraction. So there is no potential energy. So that is an ideal gas. So ideal gas is having only the kinetic energy. Now students, you all know root mean square velocity is directly proportional to the absolute temperature. It means kinetic energy is due to the temperature. It means that internal energy of an ideal gas is a function of temperature only. Is it clear? There is no fun of repeating it, because if you want to again listen, you can rewind and play. Okay, now I'm talking about the internal energy of an ideal gas, which is a function of temperature. And an internal energy of an ideal gas is a function of temperature. And internal energy of a real gas is a function of temperature as well as pressure. You will put a question, how pressure? When the molecules are very close to each other, they've got an attraction. So volume is this. I should say it is also a function of volume now. So when you move it away, you have to do work. That work is due to the molecular attraction of the gas molecules. Dear students, when you are making the two molecules away from each other, you have to do the work against the molecular attraction. That is also the work done. Work done never go waste, and it is stored up as the energy of the gas molecules, and hence it increases the internal energy. Therefore, internal energy of a gas molecule is a function of temperature as well as volume. Larger is the volume, lesser is attraction. So lesser is the work done, almost negligible work done. So it is behaving like an ideal gas. So internal energy is just the function of temperature. Smaller is the volume. Molecules are close to each other. There is molecular attraction. Work has to be done. That work has to be done to make the molecules away. That is stored up as what? Internal energy due to the potential energy. So that is a function of volume. So that is a real gas. The internal energy of an ideal gas is a function of temperature alone. Internal energy of a real gas is a function of volume as well as temperature. So dear students, I hope it is clear. It's all theoretical lecture I had given to you. I tried to explain. Dear students, you can post me your doubts. I will upload through the videos. And due to some my prior busy schedule, it's a bit problem I'm facing to be on the online live, and I promise you I will be uploading the all videos and on the YouTube, and you can go through it, and if you have any doubt, just send me on the WhatsApp or the comment box. So stay blessed, stay happy, be careful. COVID is still there.